Hello, my name is Nurshaya binti Hasanuddin. This is my friend.
My name is Umi Kalsum binti Awangsani. So I want to explain about oscilloscope. Introduction of oscilloscope. Oscilloscope is a device that allows the amplitude of electrical signal, whether they be voltage, current, power, and more, to be displayed primarily as a function of time, the basic instrument for the study all types of waveforms. An oscilloscope, sometimes abbreviated as scope, is a voltage sensing electronic instrument that is used to visualize certain voltage waveforms. An oscilloscope can display the variation of a voltage waveform in time on an oscilloscope screen. Main basic function of oscilloscope. First, measure AC/DC voltage. Second, measure AC/DC current. Then measure the time of frequency. And lastly, measure the phase differential between two waveforms. This is the pitch about analog oscilloscope. The front panel of an oscilloscope is divided into four main section levels: display control, vertical control, horizontal control, and triggering control. When using an oscilloscope, we need to adjust three basic settings to accommodate an incoming signal. First, the attenuation or application of the signal. Use volt per division control to adjust the amplitude of the signal to desired measurement range. Secondly, the time base. Use time per division control to set the amount of the time per division represented horizontally across the screen. And then lastly, the triggering of the oscilloscope. Use the trigger level to stabilize a repeating signal or to trigger on a signal event. Display control. An oscilloscope front panel includes a display screen and the knobs, button, switch, and indicator used to control signal display. As mentioned, at the front of this section, front panel control are usually divided into vertical, horizontal, and trigger section. It also includes input connector. Vertical control. Vertical control can be used to position and scale the waveform vertically. Also can be used to set the input, coupling, and other signal conditions. Horizontal control. An oscilloscope horizontal system is more closely associated with its acquisition of an input signal, normally for digital oscilloscope. Sample rate and record length are among the considerations here. Horizontal control are used to position and scale the waveform horizontally. Then trigger control. An oscilloscope horizontal function synchronize the horizontal sweep at the correct point of the signal. Essential for clear signal characteristic, the trigger max to stabilize the repetitive waveform and capture signal short waveform. Okay, the last one from me is I want to teach you steps to display a waveform. First, power on the oscilloscope, then connect the signal source function generator to the oscilloscope input channel. Then adjust the vertical control to set the waveform amplitude on the screen. Adjust the horizontal control to set the time duration display. Then set the trigger level source and mode to synchronize the display with input signal. Start the acquisition to capture and display the waveform on the screen. Use addition controls for visibility and clarity if needed. And lastly, analyze the waveform for measurement and insight.
Function generator. A function generator product different waveform produce alternating current AC of adjustable frequency. The common output waveform the sine square, triangular, and sawtooth wave. Used to test and align all circuits. They are also used to troubleshoot various electronic devices and to measure frequency. Basic function of signal generator. The front panel of generator function is divided into 5 main section level. Number 1, frequency selection group. Number 2, waveform group. Number 3, output group. Number 4, amplitude modulation group. Number 5, DC offset group. Next, function button group. Number 1, power switch. The power switch applies power to the function generator. Number 2, power on indicator. A light emitting diode LED is used to indicate when power is applied to the function generator. Number 3, frequency selection group consists of frequency range tree to set the frequency required. Function button group. Amplitude modulation group consists of amplitude knob 9 to increase the amplitude of signal. This button should be adjusted clockwise to increase the value and anti-clockwise to decrease the value. Next, waveform group consists of waveform selector 4 to choose type waveform, either sine wave, rectangular, or triangle. Function button group. DC offset group consists of offset ADC 8. ADC offset control is provided to allow the DC level of the output waveform to be set as desired. DT control 6 to symmetry of the output waveform. Waveform selector 4 to choose type of waveform, either sine wave, rectangular wave, or triangle wave. Function button group. Output group consists of output 50 ohm, square wave, triangle wave, sine wave, ramp, and pulse waveform is provided. Use BNC connector. Number 9, sweep group only digital function generator. Sweep is used to set the frequency output. It could be swept up or down in frequency using linear or log sweeps. Sine wave, and not sine wave, as has been seen in some cases. A signal that oscillates somely either side of a central value, normally 0 volts. Sine wave can be expressed as the sine of the angle, where there are 360 for each cycle, or 2 radians. The sine wave follow the amplitude for any given point can be calculated using VC, where V is the peak voltage, is the angular velocity, and it's the time. Square wave switch between 2 values. Square wave have the same amount of time in each stage. There are square wave of the all. Important characteristic of a square waveform apart from the amplitude and frequency period are their rise and fall time of the edge. These can be particularly important when driving logic circuitry. Type of waveform. Rectangular waveform, full straight. A rectangular waveform is a square waveform but with different times within the different states. This makes the waveform have a regular shape